Oh, it's just
There
starting
we
now.
go. There we go.
I'm
Sorry about
sorry.
that, Deepak. I realized when we're passing control to each other. So we're going to do this again.
Okay.
My name is Matt. This is Deepak. We are actually doing our fourth podcast. This is very special to me because Deepak is my first CEO, and he's representing NetAI. And I just want to let everyone know, just setting the table, I'm not getting paid for this promotion. There's actually no promotion. I'm not getting paid for any of it. And I'm just doing this for the sake of what is going on with AI. Why are we getting so many different messages in LinkedIn and that about this AI and that AI? And I think Deepak has a lot of really good information, being that he is the CEO of NetAI. And before we get into all that, Deepak, will you please go ahead and just introduce yourself to us and just let us know a little bit about yourself?
Yeah, thanks very much, Matt. It's a great podcast. Thank you very much for the invitation. I appreciate it. And thanks to your wonderful audience for taking time from their busy schedule to listen to us. The way I started this, I was a network engineer myself. I got my CCNA about 20 plus years ago. And I started off my career as a network engineer with flying fix into companies like back then it was MCI, Toys R Us, fixing network problems. I was working for Sun at that time. And then I built a actual tool called TraceNet in X Windows Motif in C++. Then I went to Verizon where I learned about service provider networking. I was involved with the architecture of the MPLS network, the core, then the Metro optical rings, and then the backhaul. And then the last few years of my career at Verizon, I was promoted to Verizon Labs to analyze all this data. So I worked with all the different cross-functional teams that had so many different types of tools in monitoring the network. We had Bricks for SLA, we had OpenView, we had SAV1 for the performance monitoring. And the problem was many different tools were doing functionally the same thing. For example, HP OpenView and SEV1 were actually scraping the same CRS devices and even some of the 10Ks. And then they were complaining the CPUs being overloaded. No wonder you're actually doing a full SNMP scan of the same, getting the same data. Why do you need to have different tools? So
Yeah.
they asked me to put together a next generation network architecture. And I realized that there's a big gap. There's so many different siloed tools. And even if you wanted to correlate it, by the time you get access to the data through the APIs, it would be kind of out of date. It wouldn't be real time. And the granularity would be actually different. So I started getting into analytics, and then I joined Google for 8 years, where I learned a lot more about AI. I finished my PhD in machine learning at that time. And then I came up with this idea, and that's how this company started. It takes all different types of data, and it uses the right type of machine learning for the particular use case. And
Yeah.
then I came up with this different approach where I was lucky enough to talk to some of the smartest people in the world. And the biggest impact that happened today was the actual transformer. And the key component of the transformer model, which is what all LLMs are based on now, was the attention mechanism. So I actually talked to Ashish Vaswani, actually met with him, we whiteboard, and we realized that LLMs are not appropriate for networking. And that's pretty
Okay.
much how we started this. Yeah.
Yeah, and I think that's a good segue to just jump in. You're speaking to a little bit of my experience. I jumped into a large telco, Charter Communications. They bought Bright House, Time Warner, and I was asked to kind of orchestrate how to integrate all their devices into a singular, uh, not a shell, but more of a framework. So I was kind of following along your footsteps a little bit. You're way ahead of me in many levels, and I'll give you that. But I was actually coming up with a way even before AI where we were going to monitor through decision trees what techs were doing. And I was using the Pareto principle, the 80-20. So in a way, I kind of that precursor to what you're talking about, right? But you got off and went into Google, like you said, you talked to the brightest minds. You're hitting it this space pretty hard, and you have a lot of insight. So I actually like where your trajectory went, and I think that's going to really help that next generation of learners and users. So do you want to actually talk a little bit about that, the challenges that you were facing?
Yeah. So if you don't mind, I'll present my screen. I think that might be easier to explain visually.
Absolutely,
So
absolutely.
one
Yeah.
one of the questions that get asked quite a bit from our customers is, "Hey, Deepak, what exactly is the difference between LLM and GNNs in the context of AI ops?" And basically, as you can see in my screen, on the far left, you have the network. You have routers and edges. And with LLM-based models, you have to convert all of these routers and edges, and you have to train the model. And the way you train it is you have to put every possible permutation combination of here's a fault and here's a root cause. You need that question and answer to train them. And guess what? They're all words. You have to take all these embeddings, you have to convert it. You go through a feed forward network to fit a model, and then you reconvert those vectors back into words. And you're guessing at answers because it's fundamentally based on probabilities. Now, the biggest problem with this, it's non-deterministic because there's no possible way to get every possible permutation combination of trained data to cover every case. Whereas in graph neural networks, the reason why it's so much more efficient is because you capture the routers and edges directly into a graph neural network. So you understand the structural relationship between routers and edges immediately, and you get exact answers. There's no hallucinations here because based on the data, it's exactly correct. Whereas in this case here, you're actually guessing. And not only are you trying to convert words, you're going through multiple levels of transformation. You have to have multiple billion, byte uh, parameter models, huge models. So it's very computationally inefficient. It's like using a hammer to fix everything you have. Everything is a nail. If you want to if you have to unscrew a screw, you use the claw side of a hammer because that's all you have is a hammer. So the reason why this is popular, I keep getting asked, well, then why is everybody using LLM? Well, guess what? There's a lot of open source. There's a lot of documentation. So it's very easy for anybody to just recycle open source and get something to fit work. And it's still better than what's available. But is that the best solution? Do they have a lot of headroom to grow? That's the question. For us, I spent quite a few years while I was doing my dissertation and while I was at Google to figure out how GNNs work. They're very complicated. There's not too much documentation. There's not too much open source, but that's the innovation that we provide. We provide real innovation. We don't recycle other people's work. I think that's the main difference that I think we can take a look at. Yeah.
Yeah, I think that's a very compelling point to make is that there's such a I want to say it's a craze. Almost like, is it fair to say, like in the early internet days, people were just so quick to throw up a web page, throw something up there, get some kind of presence, but obviously one page is better than the other. There's certain metrics and things that you can capture. And now we're talking about really going under that next layer, getting into the underbelly, if you will, and really talking about these language models versus what you're proposing within your NetAI platform. And I think at this point, I want to kind of venture into when I'm talking to students and I get a proposal or some kind of a idea like this, I always try to pull it back into my team and think, how is this going to help our organization long term? Right. I do realize that with this type of GNN, the mean time to resolution, it's going to keep dropping as the agent gets trained more and more on the intrinsic data of that network. So over time, there's this added benefit that the bot gets trained to know it as well as I do, maybe even faster. And I'm totally fine with that. I'm always about working smarter, not harder. But then there's the element of how do we know it's the right fit? And so what I would tell my students and then veterans coming in is you don't just, you like the idea and the concept, but then when a boss asks you for a solution, what is the next hot thing? I always present 3 options. Okay. And the 3 options are very simple. You have the one that where you build it, and it's usually my Python scripting, and it's usually addressing one issue. And it's good. It works. It's functional. And I kind of relate this to the Yugo. Back in the 80s, there was a car, and all it was bare bones. It didn't have all the fancy bells and whistles. It's a car. You can get in it, and it takes you from point A to point B. You're done. So scripting is really good in those one-offs. But then as the demands of learning more, the intelligence, the gathering more information becomes more of an issue. Now it becomes this full-blown application. So I immediately go into my next mode, which is your Honda. The serviceable vehicle, very dependable, but it's something that somebody else is bringing. Maybe it's open source. Maybe it's got a low threshold price point. But it may not address all the issues you have, which then you end up having to do your own scripting too. And then finally, I have the third option, which is your Cadillac. That's basically, it's got all the features you want, plus you're buying for the future. You're projecting into the future. And since we're talking about cybersecurity a bit on my podcast, one of the things I want to do is try to stay on the par, maybe a little ahead of the hackers, kind of maybe get agents like this that knows the network, can give us really good insight, valuable feeds to kind of feed into maybe other agents. So to your point, this is what I tell students is you get some new technology, but you want to frame it up and you want to give your employer at least three options. And that way it gives the employer time to really evaluate from a technical perspective your vision for the future of the network, but then also budgetary concerns. And then when you think about getting back to your model, if the mean time to resolution is faster than a human, well, there's a financial justification for that as well. So all these things get kind of pulled in together. And again, it's not to say that this is the next big thing. It probably is. But the idea was to give the employer options. What do you think about that?
I totally agree. Absolutely. There's been some great people so far that really added value to move the industry forward. John Capobianco from Selector AI. He's a wonderful, wonderful, unselfish guy. He's put a lot out there. It's
Isn't he
wonderful.
amazing?
He's amazing. Big
I just
John.
sing his praise every time. The guy's amazing.
Yeah.
So
By the way, we're both
I'm
fellow
glad you picked
Canadians.
up on that right away.
We're both fellow Canadians. I born and raised in Canada, grew up in Canada, did my undergrad at Carleton and in Ottawa. But he's done some great work, and I'm a great fan of John's. The only thing is that the concern that I have is that LLM-based agents are not the best thing for networking. The reason why is because when you take a part of an answer from one agent to another agent, the error multiplies. So the fundamental architecture of LLM-based agents is that the error multiplies. So as you start turning around response queries to other agents, that error is multiplying. It's basic statistics theory that when you have items in serial, the error multiplies and it's devastating. That's why you always want to have redundancy in parallel, then the error is reduced. Now, the other approach that we've taken is different, is we use GNN-based agents. So that way I've already taken out the error factor out of the equation. But the reason why it's hard and very few people are doing it so far that I know of is only Google has mentioned in one of my blog posts that they're looking at it. And Apple now has come up with a very nice paper showing the limitations of LLM. So what we've decided is to spend a little bit more brain power and effort in understanding how to use GNN-based agents, GNN-based AI ops. It takes more effort because you have to reinvent a lot of things yourself that are not documented. You can't just recycle other people's open source for GNN. But guess what? The benefits are tremendous. And the main reason is that the headroom for growth is far more. The problem with the LLM-based agents, you spend more time dilly-dallying, trying to put guardrails in, trying to get your right answer, and you have to spend a lot of time patching fixes to get the right answer. And you do it by a combination of adding more training data or adding more filtering and rules. And guess what? You're getting back to the old rules-based event correlation root cause, which it fails because you have to keep updating it. Whereas with GNN agents, they get smarter. They get smarter, as you mentioned, over time. But as long as you start with the right fundamentals, then you're in a much better position.
I think that's a really good point because one of the challenges I can speak to just from my own experimentation is, those false negatives. From a networking perspective, we get all these alerts. Sometimes we get sort of what's the word I'm looking for? You just get overloaded with the
Yeah,
same false negatives, and then you stop paying attention to it. And
exactly.
so that's kind of the concern I have. Like to your point, networking, although it is, based on science, based on the protocols that have been developed all the way, it goes all the way back. There is the human element of making those good decisions. So when you're saying this GNN is going to get better and more efficient, I'm just naturally expecting it to kind of be able to make those appropriate inferences, which to my mind, when I did try to use a large language model, I actually had to upload my own book I wrote. I wrote a book, and then I had to train it on how to make the inferences based on the chapters in the book. And it took a lot of work for me to do that. So, that's kind of where I'm seeing if GNN is able to make those inferences correctly and weed out the stuff that we don't want to focus on, but just on the critical aspects, I think that's a win.
Yeah, so that's a very good point. Is that using the RAG-based approach is also quite important because the RAG-based approach will have the exact commands and troubleshooting commands for specific vendor-specific implementation. If you get this syslog, it means this. So you want to get the RAG retrieval augmented generation system. There's a lot of different types now, and they're getting better, but they're actually dependent at the mercy of the documentation and how often you're able to update it with the and same thing goes with LLM based models is that if there's a change in the network, it takes a long time for the LLM to be able to understand, oh, this link is gone, this router is gone, and you have to retrain it. Retraining an LLM, even if you're just doing fine tuning with LoRa, it's not trivial. And how often does that happen? So basically, by the time you get an inference model, it's already out of date. With graph neural networks, as soon as a link or a node is out of commission or you add it, it incorporates it directly. We do a complete rescan of everything and we understand the structural relationships between every router and every link at every point in time. So you're getting the most accurate information. It's fundamentally far superior than other approaches for networking, though. It's not the
So
best for other applications, but for this one, we found it's far better. We tried the LLM based approach because we also know how to recycle, open source code. We're getting far better answers with GNN than anything else.
okay, so NetAI is really banking on the GNN model. That's good. The Just as a seasoned network engineer, when I hear an application doing the rescan automatically, I think network traffic. I think what is that noise level on the network. So one of the things that I'm concerned about based on different networking protocols, and this actually speaks to my students, regardless of whether you do OSPF or EIGRP, some small versions or some small campuses may do that. And then there's outages and whatnot. Can you walk me through what that scenario might look like? Let's say there was an isolated outage on a campus. How would the GNN, be able to work through that?
Excellent question. I guess talking about. So what happens is, let's say there's a structural change in the network. And what we do is we do a lot of tricks. Getting that last 10% takes 90% of the effort. We've actually been in business since 2019. It was Net Analytics before, but then we were asked to change it to NetAI.ai, which we have a trademark on. So we changed it to NetAI. But what we do is when there's a structural change, we do a lot of tricks to reduce it. We use gRPC compressed. So even now, as links are getting faster, it's not even 1% of the network traffic.
Mm.
It used to be a big deal, but the reason why we know how to do multi-processing, multi-threading. In the old days, Python was not really multi-threaded because of the global lock interpreter. So now it's really good. So
Yeah.
we use we went back to multi-threading. So we know how to scale these graph neural networks. There's only a few guys that really know how to scale graph neural networks, and the guys from Stanford at Forward and Resolve.ai, those guys know how to do that. They're really smart, of course. And Jure Lekshevich, who's just started Como, they really know how to scale graph neural networks. It's not easy.
Right.
So we know a lot of tricks on how to scale this. So we have a demo I can show you quickly that we can handle 100,000 nodes, no problem. We're working on a
If
project.
you want to, yeah, we got time. If you want to show something,
Sure. Let me
maybe
just,
your dashboard or something,
yeah, let me
that'd be
show
great
this.
for the students.
If I can reshare the screen, uh, window, here we go. So basically, in our product, the first thing we do is we scan the entire network, and we constantly update this. And at the end of the day, what is the value we provide? We provide everything you need to actually fix the problem. Uh, for example, here it will tell you exactly what the issue is, and it'll tell you exact commands to fix it. And we do that at very fast speed. So we get a burst of alarms. We can resolve this quite quickly and accurately. So everything for a junior NOC engineer to be able to resolve it, you don't have to have all these agents and what questions to ask. We already have that built in. There's also a chat bot that you can ask questions about the network if you want to. But we have some examples of deployments where we have, quite a, I believe this one, we can handle a million nodes. If you zoom in, it's quite, these ones have alarms in them. So we can really scale this, and you can see the speed at with this is visualizing it.
Yeah.
So I don't want to turn this into a product, but any customers that are interested, please feel free to reach out to Mike Hoffman, who's also a veteran in the U.S. Navy, by the way. So we
Yeah.
totally support veteran. We know the contributions. As a matter of fact, when I was at Google, I did hire veterans, a tremendous work ethic,
Mhm.
tremendous work ethic. So that's one thing that we really appreciate, and thank you for that.
Yeah, no, I think that's another thing. I personally have not served, right? I come from a family that did serve in the military, but there is this ethos, and the ethos is basically discipline and integrity.
Yep.
If you have those two, they'll work with you. But what you're showing me right now is it kind of reminded me of something that I was working on at Charter. Again, I go back to that just because I was able to use, hooks and triggers in a very rudimentary way. So I was applying the Pareto principle. I grabbed the top 3 common issues that all NOCs and SOCs were doing. I would curate those top 3, and then I would have a routine that if this happens with your database, do X, Y, and Z, and basically automatically triage, fix it, send us an email in the morning so that developers walk in, they know exactly what it is. And we did our own coding. And I called it the self-heal system because there's so much of this busyness that gets human people, their time gets eaten up just doing stuff that quite frankly could have been automated, right? And so now I'm seeing these agents, and the one you're talking about with this product where, okay, it's already triaging for you. It's already presenting the solution. Now, I think what it is that, and this is just me just being a human being, where is the line between showing us and then actually doing it and then causing an outage? Right? Because everyone's worried about, oh, if I hit this button, we don't really know what the bot is doing. Can you walk through some of that logging or recording?
Sure. So these are some of the examples that we actually start injecting complex problems, and we'll see the AI kick in and actually work. So what we do is, to be honest with you, we've taken a lot of the work from AI agents, but the problem is that, again, getting back to the LLM-based agents, there's a lot of errors and there's a lot of non-determinism. So what we did is we refactored it. We refactored by using graph neural networks based agents and getting that last 10% of performance and accuracy, and refactoring it has given us the ability to provide the exact answers. So a lot of times you have to actually, you get an alarm, you don't have enough information or not enough context. So you have to actually get more information logging in. And we do that all automatically at the optimal manner for that use case. So by triggering off different agents that have to run in a different process in a different location, there's a lot of under the covers latencies and computational waste that you have to do. We've refactored and made it more optimal. You can't survive at Google for 8 years unless you know how to write good code. And you're always on trial. Every 6 months, you have to justify your existence, and other people have to vouch for you. Oh, this guy, did he really do this? So it's not easy to survive at Google for 8 years. So we learned how to do really good coding in such a way that we deliver results. So that's one of the things that we like to show, that this product will actually prove itself. And one of the things that I like to share is that we do 2 things. Here's an example how we dramatically improve the productivity. We see about 5,000 tickets over the last 60 days, and we were able to correlate and find the root causes of 7,000 of those. If you solve the 7,000, you automatically fix the correlated events. The biggest problem with today's network operations teams is they're dilly-dallying, trying to chase every symptom, and you still have the root cause that's still festering. That's a complete waste of time. So we automatically prove the value of this by improving it by 50%, by not wasting time on the correlations. By fixing the root cause, you automatically fix it correlated. And then further to that, we use AI on the root tickets to find the exact what happened, why did it happen, and here's the steps to fix it at a fraction of the time and effort it takes a normal network engineer. We do all that for them on a silver platter.
So that's actually a really good point, and I can't believe we're almost at the end of the 30 minutes.
Oh,
But I do want to highlight the point, and this is what I've been trying to present to actually in a lecture, is the human flaw of falling into the hardware software loop. Is it a network problem? Is it an application problem? And if you really follow the way natural tickets flow, sometimes it gets caught in this logical loop.
yep,
Well, it's the network guys. No, now it's the application guy. No, it's the network guy. Da, da, da. Where if you find the correlation immediately, then you know where to escalate right away. And I think that's what the agent just does.
yes,
But when we're dealing with human beings, instead of saying advanced, junior, I was talking about mind models where first, second perspective. In this case, your agent is actually running in first perspective. And that means humans will be that second perspective standing out there looking at the whole picture. And I think that's advantageous because humans are better at pattern matching. You know, the
yes,
minute there's too much, like you were showing in your diagram, a million points, your mind just goes blah. It looks like a puffball, right?
yep.
Like your mind is trying to associate, but then as you drill down into the root cause, now the mind can act. And so that's what I like about this is this relationship between the application, the agent, and the human being
It's
in
very,
those perspectives.
it's
But
very
I
similar.
really that this was something else. This is
It,
a great podcast. I can't believe we're already only at like a minute left, Deepak. So I kind of wanted to round it out and say thank you so much.
mhm.
In my first CEO, is there anything you want to share to the students or people listening about
Yes,
this business?
it's very similar to when humans invented guns. You always need a human. Instead of using clubs and sticks in the old days when you had to do war, you guns just made humans more effective. They didn't take away jobs. You still need soldiers. You still need two countries that hate each other for whatever reason. So the guns makes everybody more effective. The same thing with AI. It's not going to take away jobs. It's going to maybe reallocate them. Instead of guys who are going to be making clubs and spears, now they're going to be making guns. So it's a reallocation just to make everybody more effective and move the industry forward.
I agree. I agree completely. What I'm seeing, and this is because I've lived in the space of being creative. You've lived in the space of being creative at such a high level. I think other people that are fearful of being institutionalized, running through, oh, I got to do this over and over and over again, and I get it. I get some money, and I take care of my family. You get to live in the creative space now, and I think humanity is going to be able to get to the creative space.
Oh
So
yeah.
I 100% agree with you. I'm actually very optimistic about this.
Yeah. So one last word is that basically now what's happened is every top level executive has been given the mandate, figure out this AI to make us more effective. The problem is many cases the blind is leading the blind and there's confusion. And what we really need to do is podcast like yours is a tremendous service to clarify what's really going on, dude. Do I want to waste millions of dollars and years of coming this wrong path? It's not going to get anything but excuses. Oh, we couldn't do this because let's get lost. Where's the results? So that's hopefully we can clarify what's really going on. And please don't be fooled by marketing. Many of these companies have tons of look at Builder. They have raised billions of dollars. They have tons of marketing. Look at the people's backgrounds that's talking about AI. Do they know what they're talking about? That's
Yeah.
the most thing I could offer is that please take a close look at who's telling you about AI. Do they know what they're talking about? Or are they recycling somebody else's work and that's their interpretation? If you can get to the source, like there's some great people like Jan LeCun, Ilya Sudkar. Listen to those people. They're the real experts.
I really appreciate that. I think that is exactly the information people are going to need to move forward. I think that is why the podcast is positioned the way it is. It's raw, unfiltered. I'm not getting paid for any of this. This is for the benefit of the community at large. And to your point, I was really concerned based on my statistic analysis of black swans. We're going to be seeing a lot more black swans. And ironically, you're going to need the agents to identify and quickly be able to adapt to black swan events. And for
Yep.
those of you who have not taken a statistics class, don't understand the magnitude and the value of what a black swan is, I definitely recommend you doing that. That's not part of this podcast. That's probably another podcast. But the idea is that the agents can be, when written correctly, can help you. So
Yep.
thank you so much, Deepak. I
You.
wish you well. I wish NetAI well. And if you need any more information, I'm going to basically give some links down below. So thank you so much.
Thank you, sir. Thank you.
All right. Have a good day.
You too.
Free audio post-production by alphonic.com.